Oh, that intro music never gets old. Welcome, everybody. I'm Brandon Evans. I'm here with Eric Johnson. We're airing here from luxurious London, England, where we're both teaching a class right now. I've been teaching for the past 10 hours, and we can't stop talking about cloud security. So here we are, ready to talk about the latest episode of our Cloud Wars series, Cloud Wars Episode 2, Attack of the Packets. Now, in the previous example, we had a scenario in the IAM world, talking about identity and access management, that Eric has personally experienced in the field. We've seen a lot of things relating to network issues in the field, but we don't have quite a perfect real-world example for this one. So we actually put together a scenario that is basically an amalgamation of a bunch of things that we've seen in the past. So without further ado, I'm going to show the first diagram that we're going to be discussing today that involves VPC peering. All right. So in this scenario, we have two VPCs, and people are relatively good at securing their own VPCs. They are getting pretty good at dealing with security groups and NACLs and all the like. But sometimes they don't realize how these VPCs interact with each other and what kind of side effects can happen as a result. So in this example, we have Jenkins in this first VPC account in its own VPC. So these are two different AWS accounts. And Jenkins is able to talk to a variety of services as well as provision infrastructure, such as this EC2 instance in this other VPC. For those who don't know, Jenkins is a continuous integration, continuous delivery tool, and it basically manages your cloud accounts and your cloud infrastructure. So as a result, Jenkins is super powerful. It has access to many things in your account. Oftentimes, I've seen instances in which Jenkins is granted nearly administrator access. So obviously, it would have access to things like data in an S3 bucket. Now we have this attacker here that was able to get into this VPC network, and they want to get this data that's out in this S3 bucket. However, they are unable to exfiltrate data from this VPC, either because there are network rules preventing that from happening in this particular VPC, or that the teams are monitoring the traffic that's coming out of this VPC actively. So the attacker is going to try to exfiltrate this data out from this account. Now, how can they do that using VPC peering? Well, VPC peering basically makes it so that these two VPCs are in the same network. Jenkins has full access to, or has the same access as it would if it was in this VPC, because these are functionally becoming the same network. So the attacker is going to tell Jenkins, hey, I want you to download all of this data from S3, could be several terabytes of data, and then we are going to send those files to this EC2 instance in the other VPC using something like SSH. And from there, in this VPC, where we don't have quite as much monitoring or as many controls, we are able to exfiltrate that data, not even necessarily with an internet gateway, but we can even do so with the NAT gateway, because as you know, a NAT gateway is a egress only gateway. And if our goal is to get information out of the network, that's all we need. So even though in this scenario, Jenkins could not directly connect to the outside world and send data to our attacker, Jenkins was able to send data to another VM in another VPC that doesn't quite have that level of control. So this is a pretty interesting scenario. Eric, tell me a little bit about what you've seen of this in the field and what ways you'd go about resolving it.
Yeah, I mean, so I look at this diagram, it's interesting. They did a pretty good job not hooking Jenkins up to the internet. That's usually the first thing that you would look for, right? You're running a Shodan search, for example, and saying, show me all of Jenkins that's on the internet, and you find this public IP address for Jenkins, and then you're just basically hacking Jenkins and you're straight up exfiltrating the info. So I feel like they did a pretty good job at that part. So we've got no internet access in VPC1 or the CI/CD VPC up towards the top. The VPC endpoints are interesting. So that little icon, that's connecting the bucket. If you don't have access directly to the internet, you can't talk to the AWS APIs by default. So you have to put these VPC endpoints, which are essentially just network interfaces inside of the VPC. They'll have a private IP address, and that'll let you talk to S3 or the secrets manager, whatever it is that you're trying to get a hold of from Jenkins to provision that EC2 box that's over in the AWS account. So that architecture, pretty good, better than what I see most of the time.
Better than the vast majority that I see.
So you can tell that they put some thought into it. The VPC peer is, I would say that's kind of the first way that we had to connect VPCs, whether they're in different regions or different AWS accounts. So that's kind of a legacy way of doing things, I will say. It's free compared to the alternative that we can get into on the next slide. But that does essentially just connect these networks. So you've got this route table that's got to give you access, to send traffic over to VPC number 2, which ultimately provides our data exfiltration path. So that's the NAT gateway down there. That's how we'll get the data out. What do you think about controls here? So do you think both of these VPCs have flow logging or traffic mirroring on that would actually at least detect it from a detection standpoint? What do you think?
Well, as we discussed in our course, Sec 510, Public Cloud Security, AWS, Azure, GCP, and we'll talk a little bit more about that later, but I'm going to focus as much as I can on the core content here. We will cover that flow logs are not enabled on any of the big 3 cloud providers by default. You have to turn that on in order to get any kind of insights. And then, as you referred to, traffic mirroring allows us to mirror traffic from one EC2 instance to another to analyze the actual packets, because flow logs only give you metadata. They don't give you the actual contents of the packets. They only tell you how many packets have been sent, what are their size, where are they coming from, where are they going, where did they come from, Connie Joe. And I thought you'd like that one.
Nice.
So very few people are actually doing traffic mirroring that I'm seeing. I mean, very few people are even doing flow logging. So we've got a long way to go in that regard, but hopefully more incident response and digital forensics folks are, paying attention to that.
Yep. So we've got that. That's a control. Thinking this through a little bit. So then we've kind of got traffic flow to talk about. Jenkins, as you mentioned, SSH, right? Jenkins is going to have a security group on that network interface that allows it on whatever SSH port we're using, 22 usually, to connect to whatever the CIDR block range is down there in that application VPC. So that's got to be there by default if that's how we're going to configure the instance and launch our container or whatever it is that we're doing out there. So that's got to be there, which means if Jenkins gets compromised, which there's a lot of ways that can happen, right? Think of, well, let's talk supply chain for just a moment. I know that's the kind of the hot topic right now. Let's pretend we have a vulnerable plugin on Jenkins. Maybe that's how we got our foothold inside of there. Not that we'd ever have a vulnerable plugin in Jenkins, right?
And I'd really like to add to this because there's a trend going on, not only of vulnerable components, not only of repositories where vulnerable components are being compromised. Recently, there have even been individuals who've contributed code, legitimate code, and have sabotaged their own repositories, either as a protest or to send a political message. So we're really getting to the point where even people who have genuinely contributed to software that Jenkins is built on are starting to attack us for any number of reasons. It's really terrifying.
Right. And so the third-party ecosystem is obviously a concern. I'm just going to assume it's either a vulnerable Jenkins plugin or a vulnerable just Jenkins in general. The running joke is, Jenkins is kind of the WordPress of the CI/CD world, right? Where it's number one, it's written in Java. Not that there's been problems with Java at all recently. cough Spring Boot, cough Log4j. You can keep going.
WordPress
Struts.
is written in PHP.
Yeah, well, no, Jenkins is written in Java.
Well,
but
okay.
WordPress.
Okay,
is-
so that's where the comparison's
yeah,
at.
there's a whole nother beast with that. Well, let's not go there. That's, we'll get sidetracked for 45 minutes. So Jenkins is compromised. It has SSH access out to this EC2 instance. So we've got a path through the endpoints of the bucket into Jenkins over to the instance. So now your terabyte of data is down on that bottom EC2, just sitting there. And we're a command away from trying to push that out to an IP address, the attacker's IP. So what do you think we have for egress controls on the EC2 instance?
That's really tough. I mean, the default security group for EC2, by default, before you poke holes into it like AWS wants you to in order to allow you to administrate your servers, by default, ingress is almost wide open. Ingress is open within the VPC, but otherwise is blocked. So you can't talk to it from the world unless you add some rules. But
right.
Egress is wide open. Wide open.
Yeah.
You can communicate with anything over any port by default.
So if you do nothing, we can get that data out.
Absolutely.
So that's our default setting. If we go and add an egress rule, let's talk about maybe what we would have to add to it, right? So this instance, we don't know what this thing's doing based on this diagram, but let's assume it's probably talking to something on port 443. I mean, how often do you see egress restricted based on an IP range, particularly where we're going to say, hey, this instance can only egress out to 1 or 2 IP addresses on 443.
We're talking about the supply chain, all the things we have to download in order to build our application.
Yeah.
I mean, how can you even get an inventory of that realistically?
So you're probably talking to NPM or Maven or whatever. There's going to be some package manager out there you need to pull stuff from. Maybe you're talking to Docker Hub or some container registry to get your workloads running on there. I think the data's gone. In this current setup, there's nothing there that I'm convinced that would prevent that from happening from a controls perspective. So I think that's a legitimate attack path and something that could definitely happen. Probably has happened in real life, even though we may not be directly aware of it. Anything else jump out at you in that architecture that seems interesting?
Well, I think that's why flow logging is so important, because we can't really block by IP or CIDR block or security group or port in this case. What we're really looking for is an excessive amount of data being sent. And as a result, maybe there are some application level controls that we can perform, some layer 7 firewalls that could be implemented. But really, it's hard to get that right. And as a result, we try to stop what we can. We need to monitor for what we can't. And if someone's looking at this network traffic and sees 4 terabytes worth of data being leaked out of an application server, that should be setting off every alarm in the organization.
Yeah. And you've got the S3 bucket there. So that's where the data is originating from. So you should have a healthy amount of noise in your CloudTrail logs, assuming that we've got that turned on. And we know S3 data, CloudTrail logs are not enabled. Even with the default CloudTrail, you've got to go in and configure S3 events on data reads as well. So if assuming you've got all of that, you should have CloudTrail data to inform you of the attack in progress. Maybe you detect it after a couple gigs have been dumped rather than the full terabyte or something like that.
Certainly. And hey, just because a relevant comment was posted in the chat, I might as well take the time to mention this. Why is there not an implicit deny for egress? Well, there actually is an implicit deny for security groups. However, the default security group has an explicit rule allowing for egress to go out over the internet.
Yeah, Jason, so it's interesting if you compare the 3 clouds here, because AWS's acts very different than GCP's and Azure's, where they've got numbered rules. In the GCP firewall or a network security group for Azure, you can put in a top level rule with an implicit deny there, right? To actually say, if it's not in my allow list, don't do it. AWS's really doesn't do anything unless you go add a rule in there to override the default and say, allow only this and only this and only this. So it's a little bit different in how you set that up.
Certainly. Any other comments you have on this one?
I'm reading this last comment here talking about this comprehensive network bill of dependencies. And I don't even know if that's a thing. I haven't seen that officially mentioned before.
Yeah.
But that's really interesting to try to think about from all of the things that should be there and exist, if that makes sense.
It sounds like they may have actually coined that term here. It's a clever one if they did.
I like it. I'm going to steal that, by the way. So whoever posted that, I'm mentioning that.
Yes, thank you for that.
Oh, let's talk a little bit about that VPC endpoint, because this is something I've seen in the past centralized, and for a couple reasons. The first reason is VPC endpoints cost money. So each endpoint at the end of the month, you've got roughly about $15 that you're going to get charged for that one S3 interface endpoint if you're using the interface option. The gateway endpoints are free. So the S3 gateway is actually cheaper, Corey Quinn wise, right? If we're talking about just cloud economist in me, use the S3 gateway endpoint. But if you're doing interface endpoints, so that's your secrets manager, that's your ECR connection for, private container registry pushes and things like that.
Literally everything but Dynamo
everything
and S3.
else, right? $15 a pop. So if you go in and you enable all of them, which some companies will do because they don't want any of that traffic to have to go over the public internet, you're going to ring up your bill pretty good, right? So what a lot of folks will do is, this could be over the VPC peer or over a more advanced configuration, like we'll talk about as we kind of shift gears here in a little bit. But what a lot of folks will do is they will put all of the VPC endpoints in one of these VPCs here. Now, it's probably not your CI/CD one. It might be a security VPC or maybe just like a network appliance VPC or whatever. But you'd have a subnet there that has all of the VPC endpoints in it. And then through peering or through a transit gateway, which is kind of our next topic of conversation as we flip the page here, you would connect all of your application VPCs would all have a DNS entry that would route to those centralized VPC endpoints. So it not only saves some spend, but now you've got a centralized location from a network collection perspective. So all of your API calls are going to flow through that same subnet, and you've got a lot better visibility into what's happening with all those calls. So
want to head over to that architecture?
Sure. Yeah, let's jump over to the other one. This particular setup, so I've been a part of some projects lately where we've put in kind of some next level, I'll call it cloud network architecture, and using some of these advanced features inside of AWS to centralize things like I was just referring to. And the whole idea here, so Omar asked a question, so how do we know what's valid egress traffic, right? There's not really an easy way outside of IP addresses or egressing from one network interface to another, using the security group ID. There's not really an easy way to filter based on more advanced characteristics, such as a fully qualified domain name, or you mentioned earlier today, like the size of a packet, right? Or some frequency, count the number of packets going to this IP, and if you exceed some threshold, let's kill it, the connection. There's not really any way to do that just with security groups and egress out of the box. So you've got to build in a more advanced network architecture and wedge in some sort of firewall appliance to detect this. So the architecture that I sent you, this is similar to what we set up. There's two key concepts on here that you need to understand to know what's going on here. The first one is the concept of a shared VPC, which I think is very heavily underutilized in all of the clouds. AWS supports it, so does GCP. So the idea is you have what we would call kind of the network host project in GCP, or the network host account, which in this case I've just tagged as the security account. So all of your VPCs for the entire organization, now you're going to have to request a limit increase here, because I think the default's 5 or something.
Why don't they want us to spend money?
Yeah, so I mean, and I've done this. I think without question, I got to bump up to 25 or 50 or something like that, just by saying, this is my VPC host project. I need all of them for the org in here, and they'll bump it up for you. So you create a VPC for security, VPC for CI/CD, a VPC for your application, and it lives in the security account. All the subnets live in the security account. And what it allows you to do is centrally manage that. So if you're going to change anything in the VPC level, route tables, you can share security groups, although typically those are managed over on the other side in the application account, for example. But you've got central configuration of networking set up here. So that's why you kind of see the left side of these VPCs over in the AWS security account block there. What you do using the RAM sharing option, have you seen the RAM, the Resource Access Manager?
No, this is all new to me too.
So the Resource Access Manager is how you can share resources like this cross account inside of an organization. And what you do is you use the RAM share and you say, okay, I would like to share this subnet ID or set of subnets, right, for redundancy with this other account in my AWS organization. So suddenly, let's say we've created the CI/CD subnet, and we say, let's share that with the CI/CD account. And then you switch roles, you go log into the CI/CD account and go to the VPC section. You're going to see the VPC there. You're going to see the subnets there, and you can launch resources into them. You didn't have to do anything over there. Nice. So the security team is kind of owning all the network stack at this point, but the consumers or our development teams or whatever, they can use them, they can launch their instances and all that stuff, but they're subject to our controls. So you turn flow logging on once in each of these VPCs in one account. You don't have to worry about it everywhere else. It's all centralized. So that's the first key concept that is extending as you look at the AWS CI/CD one and the AWS application one. That's what we're kind of doing, is we're sharing those out to the right-hand side. What do you think?
I think that this is a pretty interesting and advanced topic regarding enterprise security architecture. If only SANS was in the process of creating an enterprise cloud security architecture class.
Yeah, I'd have to read through that, I think.
Yeah, I'm really looking, well, I mean, theoretically, if it came out in the next year or so, I'd be really excited to take it. So I'm trying to remember the number off the top of my head, but I know we're working on one. You can request that information from the What's New section of the SANS website. Shameless plug.
For sure. Okay. So we've got our shared VPCs there. So Jenkins is now running in the same account, but it's in the VPC that I own. The EC2 instance is running in the application account, okay, but it's in a VPC that I own. Now you have this question of routing. How are we going to route traffic between these two accounts where there's actually not even a VPC in the account anymore, which is kind of fun to think about. You could still use VPC peering here if you wanted to. You can still peer these VPCs together, even though they're both in the security account. That would still work. But there's another more advanced resource that luckily for AWS costs a lot more money, that gives you better control over routing in one centralized location. Instead of having 15 VPC peers connecting all these VPCs and having to check the route tables for all of those individually, you can set up what's called a transit gateway. The transit gateway is basically just a big central hub and spoke model for a bunch of different VPCs. So you can connect, if you look at the top of VPC here, I haven't talked about that one yet. That is a security VPC that lives in the security accounts. and it's not shared with anybody else. That's going to be our central inspection point for applying some security policies to network traffic. So traffic going from Jenkins down to that EC2 instance, where before it was a direct peer heading down there, right? What we're going to do is force that traffic to go through the security VPC so we can inspect it with policies. And then if it passes our policies, we'll forward it back to the transit gateway and down into the application VPC. You see what we're gaining here?
Yeah,
It's pretty
centralization.
awesome. So
Amazing.
the transit gateway and the joke, I think Aiden Steele joked about this at one point. I saw it and he goes, and if you can use the transit gateway, it's perfect, but now you have to pay a network engineer a lot of money to figure out how to use it. And it's not completely wrong. It's a pretty complicated product. I probably spent the first time I used it, and we hooked up roughly 35 VPCs to it and set up these VPC route tables. And it takes some practice, right? You're going to bang your head against the wall a lot before you get the routes right. But what you do is in the transit gateway configuration, you're going to add the security VPC. It's called a transit gateway attachment. You're going to add the CI/CD as another attachment and the app VPC as another attachment. So you've now got 3 attachments that point back to the various VPCs that we're connecting to the hub and spoke model. And then the transit gateway can have 1 too many route tables in it. So you're going to create your central hub and spoke route table, and you are going to essentially attach all of the VPCs to it and then set up routes for, in this case, the default route for anything coming from the CI/CD VPC CIDR block needs to route up to that security VPC. And anything going destined to the application VPC is also going to be forced up to the security VPC in that route table. And that's pretty much where that particular route table ends. So it essentially takes care of cross communication, east-west communication, destined from one VPC to the other is forced up to the security web. That is all possible because of a cool appliance that AWS added. I want to say it was a reInvent, maybe 2 reInvents ago. I get them all mixed up.
It all comes so fast.
But it's called a gateway load balancer.
Huh.
And the gateway load balancer is essentially using VPC endpoints under the hood. It's kind of fun. The gateway load balancer is basically a load balancer that the target group behind it is 3 endpoints that are sitting on the other end of this transit gateway network. So it's going to hit that. It's going to go through a gateway load balancer, and the gateway load balancer has an attachment to the AWS network firewall. And inside of that firewall, all of the traffic flows through it. And now we've got the ability to apply firewall policies, which gives you that more advanced traffic filtering that you wanted. So we can look at FQDNs. We can decide, you know what, it's weird that that's heading out of the door to some random domain name that we haven't approved. Like we're only supposed to be talking to GitHub. Why are we talking to Eric's awesome malwaresite.com, something like that?
That's a great domain name.
Is it available? Maybe we should buy it.
Yeah, someone in the audience before it's too late.
Yeah, not that. So Ben Allen is one of the instructors and authors for 540. We already own the Strangers on the Internet Docker Hub organization because we like to put our test samples in there. So maybe we should get Strangers on the Internet. I think that'd be more fun.
I have a feeling that's actually taken.
That's
a much better domain.
We'll have to buy
Eric's Evil Malware website.com.
We'll have to buy a weird TLD for that one, right?
Yeah.
So, okay, I digress. Our traffic now, so let's assume CI/CD wants to talk to the AWS EC2. The transit gateway has routed you up to the security VPC. So we're now right now sitting inside of that security VPC. East-west is the E/W subnet. And that doesn't have to be a network firewall managed AWS. That could be your own managed, Suricata instances. It could be a Palo Alto or a Fortinet firewall. It doesn't really discriminate. It doesn't matter because all we're doing is hitting 3 network interfaces through the gateway load balancer. and those are attached to the firewall directly. So that's how your traffic ends up there. How do you get the traffic back to where it was supposed to go? So you've got to go back into your transit gateway route tables, and you have to add a new route table and attach it only to the security VPC. And then all of the propagations that are inside of there, all you're going to do is say all the traffic leaving the security VPC, if it's destined to the CI/CD CIDR block, go to this VPC attachment. If it's going to the application VPC, propagate it down to that CIDR block. So that's how the traffic bounces and then gets redirected back to wherever it was supposed to go post-inspection. So what we've accomplished here, and Omar asked the question, so are we just isolating with the security VPC? I would say it's a lot more than isolation, really. What you've ultimately put into this whole architecture here is a choke point, right? Where we can actually say, does this traffic meet my firewall policies? And if it does not, we'll block it. That east-west traffic is not going to go. If it does, we'll forward it along.
It's almost like a checkpoint for security to check for a variety of different parameters before forwarding along the traffic.
Yep, absolutely. And the transit gateway is the required appliance or product from AWS that's facilitating moving that traffic around successfully to make all that work. So that's kind of fun.
Yeah, it sounds complex and expensive. As Andres mentions, Andrea, hope I'm pronouncing your name properly, mentions that if you're using a cheap network, you're probably not doing enough. You're probably not paying enough.
Yeah.
So just for context, is this transit gateway more or less expensive than Macy?
It probably depends on how much data you push through it, because just like all things networking in AWS, you're charged based on consumption and or bandwidth. So if you're moving a ton of traffic, it's probably more.
That's terrifying. I have a new resource, a new feature, a new service to put into my list of really expensive things. Right now, it's Macy, it's Cloud HSM, and what's the other one that's ridiculous? Oh, Secrets Manager.
This might be more than Cloud HSM, because the Cloud HSM is honestly, if you're an enterprise, it's not that much money. The HSM, well, you have to have a cluster, right? So each HSM, depending on the region of the world you're running in, runs you between $160 and like $250 an hour. But then you need redundant HSM, so you double that. And yeah, it's like $4 or $5 grand a month probably. Now, this is completely digressing. You want to hear a fun story?
Yeah, sure. Of course. What else is
You
this for?
completely sidebarred me, but
good job.
We used Terraform to build a Cloud HSM for a security account. So actually, if you look at this top VPC, there'd be another subnet in there called the HSM subnet. And that's where the HSM cluster lives. There was a bug in the Terraform provider for Cloud HSMs. So you deployed it and you got your 3 HSM clusters sitting there, right? And you're happy, everything's working. And occasionally, those Cloud HSMs will die. And AWS is smart enough and redundant enough inside of the cluster. So when the 3rd node dies off, they'll automatically auto scale and spin up a new one. So you're right back to where you were.
Yeah, hopefully they do that, or else you lose your keys, and you really don't want to see that happen. That's why we need that redundancy.
That's why you need the cluster. And
exactly.
The data does sync automatically, auto-magically between all of them, right? The problem is if you look at how Terraform manages its state, what just changed up in the cloud versus what's in our Terraform state file?
The Terraform state file is only aware of what it managed.
So one of them died, and the next time you run Terraform, not changing anything in the HSM cluster at all. So you're kind of not paying attention to that piece, right? You're checking to make sure your new bucket shows up, right? Or whatever. And Terraform, the plan command, if you missed it, it said, there's supposed to be an HSM here, and it's not. So what's Terraform going to do?
Create it.
It throws another one out there. So now you have 4. And then if it happens again, 3 weeks later, it's going to create a 5th one. And it kept stacking them up. And unless you're really paying attention to your cloud bill, or
which no one is,
setting up. So very quickly after this, and now we spent, and the cloud HSM went from 4,000 that month to like 8 or 9. And we're like, what in the heck is going on? I'm like, why do we have 5 HSMs running in here? And that was 100% because the Terraform provider didn't correctly identify the replacement.
I mean, the worst part about that is it won't be able to ever detect it because now those dead resources are not being tracked. So when you do a teardown, you're still going to have things.
Yeah. So they did fix it. And that stayed open in the Terraform provider GitHub repo for a year probably. And then I finally saw some activity on it one day, and they found a way through other characteristics to make sure that they did not do that, because obviously people were pretty ticked off that they dropped a few grand on accident, not knowing about it. So that's another thing that you could throw up here in that security VPC that other resources could use through the transit gateway if you want to, right? You have a route to it through the transit gateway if you need it. So my middle subnet there is illustrating the same concept, which is all those VPC endpoints that we had in there before. That's where we could put those. You can have a VPC endpoint subnet, and through the transit gateway, as long as you set up a private hosted zone somewhere and share it with all of those VPCs, when it requests, SSM useast1.amazonaws.com, your private hosted zone is going to resolve to a 10 whatever IP, and it'll route through the transit gateway into your VPC endpoint subnet. So that will save you a lot of money. So maybe the offset between the transit gateway and not recreating all of your VPC endpoints starts to perhaps level out a little bit, because you create them once and they're usable from any VPC in the whole organization if you have the route set up that way.
And you mentioned a property about private endpoints that I'm a huge fan of. I love the ability to enable private DNS for your endpoints, because as a former application developer and still an application development hobbyist, if a security person comes to me and says, hey, you have to rewrite all your code to point to this specific endpoint, I'm going to get pretty frustrated.
Yeah.
And that's going to take a lot of work.
Yeah.
What I love about the private DNS capability is now the SDK is automatically going to resolve to the private endpoint. And now I don't have to do any extra work to get all those benefits.
Exactly. Yeah. The DNS kind of takes care of the lookup and redirecting you from public IP, which it would resolve to normally, over to here's my private one in my own little tiny little subnet up in that security account. Omar asked another good question there. So the two components would not be a bottleneck, and I will say they're absolutely dependencies at this point, right? The transit gateway is kind of like the internet gateway and the NAT gateway, in the fact that they auto scale. So if you've got tons of traffic pushing through there, they're going to ramp up the power. That, at least in our experience, in the area that we're using this, is pushing a lot of data, like real-time traffic analytics. So I haven't seen any throughput options with that. The network firewall, on the other hand, I don't know. Maybe. I mean, you're running inspection basically on all packets flowing through this entire big network now, right? And that's going to add overhead. But the risk of not having it is you're not going to see data exfiltration, or know if I compromise Jenkins that I'm going to go attack that other EC2. You have no way to stop it now.
I wonder if this has significant compliance concerns, right? Inspecting all these packets. Are there any concerns that you'd have with that?
Most compliance says you have to do it, which is kind of interesting.
I guess it really depends on the country and region you're in.
Yeah,
I know
we're in Europe right now, or
Yeah.
the UK technically now, right?
Yeah, not the same thing.
And
Get it right.
we're different now. Sorry, I'm stuck in the past, right? But GDPR is a big thing over here, and it comes up in class a lot. We talked about it for a bit today, and I told them thanks for ruining the internet and making me click on accept cookie boxes 88 times a day. But there is some good parts to that, which is, privacy laws and making sure your information is protected, and doing deep packet inspection. Kind of, I mean, I guess the users are submitting that information through there anyway, but it's something to think about. You know, a rogue administrator could start looking in that area if they wanted to.
Just one thing on GDPR, just because this is the first time that I've been to this region after that was enacted. Just so you understand, you know, in the US, when you're prompted to accept cookies, it's like at the bottom of the page.
Yeah.
As soon as I got here, it just shows up and you can't do anything about it until you click on it.
Yeah, you
and it's
can't
just
get anywhere.
so much more intrusive. I'm like, why did every website implement this differently this week? Oh,
Yes.
it's always been like this over here.
Yeah, it's kind of interesting. Looking at this too, the other thing I think is important to realize. So east-west inspection, I would say, is a control that's underutilized because you're looking at this diagram. That's a lot of Terraform code to set that up and to get all that traffic flowing appropriately. One that is used more is kind of at the top right, where we've got our user and we've got ingress traffic maybe coming in through a public-facing firewall. But that gateway load balancer makes it really easy to have a central ingress point for your whole organization. And then your firewalls can have little NAT rules in them that will then route through the transit gateway down to Jenkins or down to the AWS account. So it does also give you that option where you can set up maybe only one internet gateway for your whole organization. And you've got that central choke point again, you know, as you go through and set that stuff up. So that's kind of fun as well.
So Omar has a question that kind of gets to one of the services I was listing earlier. Is there any way to label data so as it's exfiltrated, we can perform data loss prevention? Well, we do have a service for that in AWS. It's called AWS Macy. As I alluded to earlier, it's very, very expensive, and it logically makes sense. I mean, how can you classify data accurately? There's so many parameters that come into data classification, and they realize that they put a lot of work into that AI ML to figure out what is confidential and what is not confidential.
Yeah.
They can charge a boatload for it.
Yeah, and it does a pretty good job. So Steve Bernard, our colleague or friend, whatever you want to call him, right?
Both, definitely both.
Yeah, Steve, you're a good dude. He took Sec 540 with me years ago. And in that class, we purposely put some US tax forms, you know, like W-2 forms and things like that into an S3 bucket, unencrypted, and let them sit there. And then we kind of play around with them in the labs and stuff. And I was walking by Steve and he goes, "Hey, check this out." He had a bunch of credits from reInvent. And he said, "I'm going to turn Macy on in this account because let's just use up some free credits or whatever."
Brave.
Yeah. And I'm like, okay, you know, he's like, we're good. And within about 15 minutes, it had crawled all of the data in that bucket and it fired up a warning. Now, at that point, we didn't really have Security Hub available. So the Macy warnings are just kind of stuck in the Macy dashboard. They weren't going anywhere. Now it would fire something up in Security Hub and say something along the lines of, "Hey, Eric, you have a PDF file in this bucket with what looks like a US social security number on it. And I looked at the configuration of the bucket and it's not encrypted at all. Like you don't have crypto on, not even the AWS managed option, right?" Which is pretty impressive for a kind of machine learning algorithm to be able to go in and find that stuff.
Yeah, we were talking today about just how important it is to have that basic level of default encryption. You know, we were having a debate in the class about, you know, isn't there a performance issue or a cost issue relating to turning on just simple service level or disk level encryption?
Yeah.
And the answer is almost always maybe a little bit, but not nearly enough to justify not using it.
I mean, it's the cloud. It never has performance problems.
Sure, but you know, we're in 2022. Encryption is not
That's
like
not
this.
the problem.
It's certainly not the main thing that is going to have a performance issue. It's more network latency. It's more database query optimization. I mean, encryption is so relatively trivial. And then compare that to spending all this money to actually do proper data classification to determine what you need to encrypt. I mean, almost immediately you're wasting money as a result of going down that path.
Yeah, for sure. It is worth noting too, guard duty runs underneath the fabric of kind of these traffic flows, right? So Guard duty would also detect potentially some of this data exfiltration in those traffic patterns, because it's running even deeper than like what your flow logs are going to give you. So guard duty may have fired up an alert as we exfiltrated a terabyte of data from our original bucket anyway.
Any other things you want to show on this slide before we kill that and show more of our bright and smiling faces?
No, I think we've covered everything on there. I'm good. So I guess let's just kind of pick off any questions and things like that are out there.
Omar just added one. Can you label data so it can't leave the VPC? Just like basically, I guess you're saying filter data by tag. I don't think that's a possibility.
Now you can use attribute-based access control in your policies using tagging. So something like my user can't read any S3 data if this bucket or this object is tagged with a, super top secret value or whatever you want to set up like that. So
Certainly.
some of it's not across the board. That's not perfect. Some resources don't support that tag-based conditional filtering on it.
But that's at the IAM level, not
Exactly.
at the networking level.
At the network level, I don't believe, not to my knowledge. I have no idea.
That'd be pretty heavy duty. Now we're talking about some performance hit.
Yep. So usually at the network level, because you remember where this is running, right? You're not at like the layer 7 level for most of this. Most of this is down layer 4-ish, whatever. And you've got FQDNs, and even in that packet, right? All the packets have max sizes. So you really don't know how big the file is, right? You'd have to aggregate it all up to know what the size is. So usually it's FQDNs, IPs, ports, and protocols. It's more advanced than a security group rule, but it's still, you don't have the big picture here.
Yeah, I don't think it's advanced enough to figure out what the contents of, let's say, an image file is, and then tie that back to a resource in AWS saying, hey, this file that's constructed from all these packets, that originated from S3, and that S3 bucket doesn't have a tag, therefore block. I mean, that would be really impressive if it could do that, but I don't think we're anywhere near that, unfortunately.
Yeah. So going back to that, just if a VPC is not supposed to have traffic leaving it, the only way to ensure that is to make sure no traffic leaves it, right? You don't give it a route out to the internet. Your transit gateway shouldn't be propagating that to an egress subnet that's got NAT gateways allowing that egress stuff to happen. Obviously, your network firewall can throw a policy in there that says, hey, if the traffic's from this VPC, kill it. So there's ways to stop that, but then you run into problems like how do you patch your boxes, or how do you run a git clone command, or how do you, download things? So you can't.
It's
you got to
hard.
figure out how to manage it.
It's extremely hard to lock down things network-wise. Got to pick your battles, certainly.
Yeah, I mean, once this is all set up, that's probably not mine, because there's always a way around it, it seems like. There's been some cool research. I know I'm digressing here. So even if you have no way out, right? So think of no NAT gateway, even if it's through a transit gateway and a firewall.
Just nothing, no gateways.
If I have access to a VPC endpoint, I can now exfiltrate data. Unless you have, which nobody sets up, and unless you have a VPC endpoint policy on that endpoint. Have you ever seen the policy section in there?
Yeah, is that the policy that limits who can create an endpoint, or is this something different?
It's a policy, it's a resource-based policy that attaches to the endpoint itself. Okay. And that says who can use it and who the data can flow to, if that makes sense. So if you have an S3 policy or an S3 endpoint, out of the box from my compromised EC2 instance, I can send objects through your VPC endpoint to an S3 bucket over in another account.
Oh, I see what you're saying.
I still have a way out, right? Unless you have a policy on there that says that bucket has to belong to my org or my account or whatever, I can still exfiltrate data, which is pretty awesome.
I have seen very few organizations even implementing endpoints, private endpoints of any kind. Most data in services are just accessible via the public endpoint.
You're just happy when they turn them on, but
yeah,
you're still giving me an attack vector.
The idea that we could limit what specific resources can be communicated with via that endpoint. I mean, if you are even looking into this, your team is doing a great job.
Yeah. I mean, that means you're bored, right?
Yeah. I guess they don't have a lot of things to deal with if they're going to go down that path, certainly.
Anyhow, I will leave it at that. I think we've probably plowed through 3 days worth of discussion in about 51 minutes at this point. So
yeah, well, we've got 9 minutes left in the webcast, which means we have some time to answer more questions regarding this talk or questions about cloud security in general. I mean, feel free to spin us off into a completely different topic. It's not like we've necessarily stayed on point this whole time. But before we do that, while maybe questions are queuing in, I'll go ahead and do a couple of shameless plugs. So Eric and I are both course authors. We've written a course together called Sec 510, Public Cloud Security, AWS, Azure, and GCP. And the SANS Cloud Security account on YouTube and maybe LinkedIn in a moment is posting the link to that so you get some information. And that course is a survey course of the big 3 cloud providers showing basically in a 33%, 33%, 33% fashion, the differences between AWS, Azure, and GCP in some key areas. One of the things that I really love about the course is that we expose a lot of the things these cloud providers don't want to tell you, because the cloud provider has an incentive to tell you that they're doing everything necessary to secure your account. Very key example of that is when we talk about the instance metadata service. There was a huge issue saying, hey, we patched our service. They said, hey, we made a new version of the service that has a new defense and dev mechanism. Our existing one is still secure, and we're going to still enable it and support it by default. So we like to, take blows at them when they deserve it, because you're not going to get that kind of content from the material that they put out, because they have no incentive to discuss it where possible. So if you'd like to learn more about that, we're located at sec510.com. We have a corresponding certification called the GIAC Public Cloud Security Certification, and I'd love to see you in a future event. And Eric has also written a course that I've had the pleasure of teaching, Sec 540, which is cloud security and now DevSecOps.
gotta add the security. They're invited now.
They're invited to the table. Eric, you want to add a couple more details on 540?
Yeah, and there's a question in here that says, hey, is this stuff covered in Sec 540? So I'll differentiate. 510 is all about the benchmarks between the clouds, what our default configurations are, and what a kind of step-by-step checklist would look like if we went in and hardened all those services. 540's job is to make sure that you know how, from an automated standpoint, to use the DevSecOps tool chain, which is CI/CD and running some security tooling from the command line. You're going to get your Linux Kung Fu in a bit, as well as learn how to write some YAML and some HCL for Terraform, and learn how to write Jenkins Groovy syntaxes and things like that. And once you've got that down, we then go into automating cloud deployments and building cloud pipelines to go in and build all of the things we just talked about, but do it by pushing a button and not by clicking 39 boxes in the web UI. So I think that's where the main goal lives, at least in Sec 540. And I'm happy to chat about that later if there's more questions there.
Yeah, and one of the funny things about that is, even though 540 is a course that has DevSecOps in the title, I think it's actually most valuable to people who are strictly in security to help understand the process that DevOps is involved with, because otherwise you're not invited to the table because you don't understand the culture around that, what their goals are, et cetera. So it's a really, really good introduction to that area. And there's a lot of security people that, if they haven't bought into some of these trends, they really need to start doing so, or they're going to be left behind. Have another question here that says, any clues on how Macy is containerized and machine learning algorithm that is analyzing all data has its hooks in all the data? If data is static, it's essentially in a Schrodinger's cat. Once analyzed, you're collapsing that function. Well, that's a kind of complex comment, very clever and flavorful. If I understand you properly, the question is, how is Macy isolated from other infrastructure and services? Because it has a lot of power. And that's a great question. How much access does Macy have at the IAM level? Do we have to explicitly give Macy permission to talk to the services in which it's analyzing data?
I do not know that off the top of my head.
I hope so.
I suspect it's kind of like Security Hub or Config or one of those services where you enable it, and under the hood, it creates a service linked role that is going to be attached to that service. And then I'm assuming that it's going to go in and give that service linked role access to the other services with kind of a managed AWS policy under the hood. But I don't know. And if it's a managed AWS policy, we've seen bad things happen in there before in the past as well. So yeah, there's always who's watching the watcher. Somebody dropped in there. I'll tell you who is. Scott Piper and some other of the very in-depth AWS security folks, they have bots that crawl the AWS managed policy repos and look for those misconfigurations. And then they immediately call out AWS when they screw it up. And usually AWS fixes it pretty quick, but it's going to be one of those services, right?
Yeah, I was just reading up on exactly what you're describing. There's a repository called MAMIP, the Managed AWS, something that detects managed policies.
Yeah.
And it found some examples of managed policies just being changed in ways that are completely inappropriate.
Yep.
So far, it's only found one example in which AWS has actually owned up to it and made a statement on the subject.
Is that the S3 one?
That was the recent one regarding, that where support agents were allegedly able to
read the data.
Yes. The statement said that there was a defense in depth mechanism that prevented that from happening. But are we really going to trust them considering the comments they made about the IMDS?
Inside the fabric that we couldn't see.
Yeah, I don't know. I don't know how much I trust that.
Maybe that's a topic for a different day.
Yeah, I mean, I think this all goes to show you just can't learn enough about the cloud. You can study this all the time, and there's still so many questions, like what we just said about Macy and IAM. Someone did chime in and say that yes, there are IAM policies involved with Macy. You have to grant it the ability to access various services, but if security says, hey, run Macy to scan all the data in your account, it's very likely that Macy will have too many permissions, and then such a trade-off. Why is everything trade-offs? Why can't anything just be obviously good?
Well, we got to keep working somehow, right?
Yeah. Job security. Job security. Am I right?
Good stuff.
That sounds like a pretty good note to end on.
Agreed. Thank you all for attending. It's good to chat with you again. We'll see you back for round 3 in a few weeks out, I think, right?
I think we're shooting for mid-May.
Sounds good.
Early mid-May. So thank you so much. Have a good afternoon if you're in the States. It's very much late dinner time for us, and I hope you have a wonderful time. And until the next SANS meeting, see y'all.